lighting and lighting control have evolved quite dramatically from earliest lighting using fire over incandescent lighting to LED lighting. And much in the same way, lighting control has evolved a lot. For the first probably 100 years, at least, of lighting, lighting was controlled by wired controls, no wireless functionality inside. You press a switch, the light goes on, and this was a true miracle when it happened. Sure enough, in the evolution of lighting, there was also an evolution in control to wireless controls. Phase 2 of wireless controls allowed you to control your lighting system from anywhere within the room, to smartly place your switches and controls, and to make your lighting much more adaptable. Now we have entered phase 3 of lighting control, and we start to look towards data-driven use cases. So not only is the function of the lighting network to provide you light, good light, but the function also increasingly becomes to provide and transport sensor data for analytics and actions. And the lighting network is uniquely suited for that for a very simple reason. You have very many light sources around you. So the next node in your network is never very far away. So this part is very well known, but still today, most of the lighting network and smart lighting controls are sold on quite traditional propositions. So the easiest thing to explain today is you install a smart lighting system, and I will demonstrate you the amount of energy and cost savings that you will achieve, and the amount of compliance with regulation you can demonstrate. So typical use cases even today are focused around dimming, automatic shut off, and daylighting. And then your typical pitch goes like this. You change your lighting to LED, and then you will save a lot of money. And then step 2, you will add controls, and you will save even more of money. So this has been the traditional tune of selling smart lighting. What we've observed over the last probably 5 to 10 years is an increasing focus not only on compliance and cost saving, but also on the quality of life and of light in particular. So this is something that has been discussed many times at LPS symposium, from forums like a Good Light, from talks about human-centric lighting, highlighting the importance of providing good, well-suited light, not only from a quality perspective, but also from a health perspective, and from a comfort and ease of use perspective. So you want your lighting to be high quality, and you want your lighting to be your partner throughout the day. An example of this is, for instance, a hotel lighting installation, where increasingly also hotels put a strong emphasis on differentiating the guest experience by lighting systems, by providing different lighting scenarios depending on the time of the day. So some bright lighting during the day, a little bit more dimmed lighting during the evening, and then a very low lighting during the night. And one of the important things, especially in hotels, is that lighting systems are easy to use. Because remember, a guest comes in a hotel, he has no idea about the underlying control theory, technology, different user interfaces. He expects lighting to be beautiful, but also easy to use. So here's an example from a hotel in Helsinki, where I wish I can go soon again. The Lapland Hotel, recreating the lighting of northern Finland, an implementation done by Mount Kelvin in Helsinki that connects both great lighting with ease of use from a user perspective. And then, of course, everybody is aware that lighting has the potential to be an IoT data network. It provides a very high density, medium bandwidth network. So it's not suited for video streaming, certainly, but it's very well suited to transport sensor data. And this is a natural expansion to go from lighting control to building insights. If we look, well, what type of insights does a lighting network provide you? Here's an example from our partner Silvair regarding the implementation of qualified Bluetooth mesh-based lighting networks. So you can see very simple architecture. You have a mesh network of lighting nodes, And around that, you have a number of sensors and switches. And what do they typically sense? These are occupancy sensors and ambient light sensors. And the occupancy information is probably one of the most important, one of the most versatile information in your system, because it tells you not only if somebody's in the room, so you need to switch on or switch off the light, but it also tells you about the utilization of the room. It tells you if a room needs cleaning because it was occupied throughout the day. It tells you how your rooms are utilized, for how much time during the day. To implement this type of use cases, a few points are very important. So number one, of course, you need a network that is capable to transport data. This network should be an open and interoperable network so that you can extend it with different sensors from different manufacturers in an interoperable way. And very important, this type of network needs to be designed to allow data reuse. So somewhat loosely speaking, there needs to be a way to get the data out of the network. If you have occupancy information available in your lighting control network, then you need to have a way to get this information towards your building management system or towards an analytics system. And this is very important to keep in mind when doing system design. Now, all of this is probably well known, has been presented a number of times. So if we look at making lighting smart, how to do that, what are the key things to keep in mind? What are sometimes the hurdles to really leverage your lighting system? So number one, of course, if you want to do smart lighting, you want to reach smart decisions, then you need data as the foundation. Data is the foundation of smartness. Without data, without insights, you cannot make smart decisions. So the network, your lighting network, needs to be able to capture, to transport, and to hand off data from sensors, both existing sensors and ideally also from new sensors, because quite often you're not fully sure what type of information you will need in the future. So for this, the use of open standards, of course, is very important, such as, for instance, Bluetooth, Zigbee, and Ocean Radio, to allow your system to interoperate and to hand off the data. Data generation has to be easy and reliable. If you want to gain insights into your building, you must be able to do so very easily. It cannot be too complex to install new sensors. You need to be able to quickly adjust and extend your system. And one of the important things is, what do you actually do with the system? What do you actually do with the data that it generates? One of the things I see quite often is you put the data on a dashboard, and then this dashboard is sometimes looked at, and then after a while it is forgotten. I can speak from our company. We have many, many dashboards, and I'm not looking very often around them. But what is very workable, and you might have noticed a tiny green glow in the beginning at my face, is a simple indicator light. This type of indicator light that you see here at the bottom is placed in each of our rooms, and it will indicate if the air quality in the room is acceptable or if ventilation is required. So this allows us in a very simple way to enforce demand and utilization-based ventilation, which has become a very critical item during the COVID pandemic. So it's very important not only to collect the right data, but to visualize it in a good way and to trigger relevant actions from that. Now, another thing that's very important to keep in mind is not only collecting the right data, but to have an idea about the scale of the data, about the amount of data you actually collect in a typical system. So here I've provided an example from a building in Frankfurt, right outside Frankfurt Airport. This is the Square, Germany's biggest office building. It's outfitted by EnOcean Alliance partners. And in this building, there are over 18,000 EnOcean nodes. So a lot of different sensors, a lot of different data. You need to monitor things like usage, your environmental condition, motion, door window status, you control the light, you monitor air quality, control the ventilation. So you need to be able to handle data from many sensors and also from many different sensors. And this means that you really need to focus on how you can collect and transport the data. And again, here, the use of open and wireless networks enables easy data transport. Because if you have a very nice wired sensor network, then every time you want to extend it, every time you want to modify it, you will be looking into a rewiring exercise. And if you keep in mind the scale of the data, that will very quickly become problematic. So EnOcean firmly believes in working in open ecosystems. So we work both in EnOcean Alliance with over 400 members, providing over 1,500 interoperable products. But we also work in Zigbee and in Bluetooth, specifically focusing on lighting applications. So now another thing that is important to understand is that your smart functionality has to extend across the value chain. So it's very nice if you have a smart lighting system that tells you a room is occupied, an area is utilized. But what do you do with this information? You need to transport this information throughout your building. You need to hand it off to building automation systems, and you need to hand it off to IoT solutions and dashboards so that your service partners can use it. So you need to build a partner ecosystem, not only in lighting and lighting controls, but also in building automation, in IoT integration, and even all the way towards the end users, which quite often are service providers, like an ISS that is doing the cleaning or is handing out the meals at different office locations. So you need to address the entire value chain or have solution for the entire value chain all the way to the end user. And there again, it is very important to set up such a value chain, to set up new use cases. You can do a quick installation of your products and you can operate them maintenance free. And now all of this has been presented in some form or another at previous iterations of the Lighting Symposium. But now what struck me a little bit is how did all of this smartness do in times of COVID? What does in times of COVID mean? The COVID pandemic has put focus on a few selected use cases that suddenly became very important. So if I look what are probably the most important use cases in a building during COVID, it's number one, the occupancy monitoring. You need to understand, is an office available or not? Is a place in an office available or not? This might depend on capacity restrictions. This might require that you clean the office in between the usage. And once the office is utilized, you might require contact tracing to understand who has used this office. And then you also need to focus on air quality. You need to enforce ventilation to ensure that as little as possible remains in the air. So these four things on the outside are things that you need to monitor. And based on this, you need to trigger alerts and meaningful actions. So and the interesting thing is, I mean, all of these are existing use cases. Nothing of this is really new. So COVID, in a sense, provided a new context to use cases that were already there. So what was previously utilization monitoring, where you wanted to understand how your different areas are utilized, is now enforcing capacity restrictions. What was previously cleaning on demand is now ensure hygiene requirements are met. What was previously automated control is now touchless control because you don't want to touch light switches and control surfaces anymore. What was previously asset tracking is now extended to contact tracing. So all of these use cases existed, and therefore smart lighting systems should theoretically have been in a very good position to address the challenges of COVID. You have occupancy monitoring in basically all modern lighting control systems, and this data alone could already significantly have helped COVID use cases. But if you look at what has really been the focus, if I look and see what was focus lighting in context of COVID, then probably the first thing that comes up is how to use ultraviolet lighting for disinfection. So this has provided tremendous benefits and a lot of research is going into that. But what I've seen to a lesser extent is how is lighting utilized to help enforcing COVID restrictions. And I was wondering, why is that? What are the lessons from that? What is it that we need to do better? So if we look at adapting to COVID, the theory is quite simple. You have an office space, you have a occupancy monitor. So in theory, it should be very easy to say there's one person sitting here. So this room is now full to maximum capacity. And after that, after this person leaves, we need to clean this specific desk. In reality, what has happened looked a lot more like the bottom side. So even here at EnOcean, we managed a lot of the COVID pandemic using signs that you place on a desk. They say, please clean. So this means that there must have been some challenges that tell us what we need to improve going forward. And this also means that customer awareness for this type of use case, for this type of possible benefit has improved. Now, what are the lessons? Why did lighting so far not fully leverage its potential to enable addressing the COVID pandemic? Number one is COVID had a very, very limited advance time window. So we went from normal operation to full lockdown within a few days. I think here in Germany, we went to work on Monday, and on Friday, we packed up all our supplies and started working from home. So there was very little advanced warning that would have allowed to adjust the system. Also, the physical access to the building, to the installation became suddenly very difficult. So for a long time, you were not able to get external personnel into your building to go and adjust your system, to do installation, to modify existing installations. And in such a situation, the ease of installation and ideally even the ability to do remote administration was essential. So if your system looked like something on the left side, and full disclosure, this is how it's looking at EnOcean. We are only renting the building, and this is what is installed here. Then to adapt this type of fixed function system to new smart lighting use cases within a very limited time window is basically impossible in this type of a situation. If, on the other hand, you have an existing wireless system in place that's built towards extensibility, that's built towards data-driven use cases, then this became much easier for you. So lesson number one, it's very important to design your system that it's not only easy to install, but also easy to adapt. Lesson number two is the importance of ecosystems. I've said it a number of times. It's important to work within open ecosystems so that your solutions and your partner solutions and other partner solutions work together. Because there are many different new use cases out there. I'm convinced there will be another challenge in 5 or 10 years. And today, you don't know what type of device you need. But if you work within an alliance of 400 members, then you have a very high likelihood of somebody else having the device that you need. So working within open ecosystems is critical to address unexpected use cases. Then number three, something that has become painfully obvious, is the importance of just works. In a situation like right now, system maintenance is a lot more than just a cost issue. You physically need to get access to the building, to the room, to the device. You need to handle the logistics for that. So all the documentation, the permissions, the keys, the replaceable, the material. You need to have the right personnel. You will probably encounter some downtime, and the whole thing will massively impact customer satisfaction. Because if this takes a lot of time to organize the first 4 steps, then your customer will have a non-working system. And this is one of the things that we at EnOcean very firmly believe in. Energy harvesting makes our devices maintenance free, and the importance of just works is a key differentiator. Now, let's take some practical examples. I've selected 3 practical examples from installations that have shown benefits of smart lighting systems. And I want to present them to make this tangible. So the first example is Kasambi together with Holders technology. Now, of course, most of you will be familiar with the Kasambi system and the Kasambi applications. It's a very advanced, very widely used smart lighting system consisting of Kasambi modules that get integrated into partner products such as drivers and dimmers, and to which Kasambi partners provide sensors, controls, and gateways. You can see on the right side some of our switches, some of our sensors, but also partner products, like a Kasambi switch from Kasambi themselves, an occupancy sensor from Danlas, and a gateway from Holders Technology. So your typical installation is focused around lighting, not so much around building automation. And this will be an open office space, a restaurant. This will be shopping and retail. This can be either bigger office installations like the BBC or the Ulster Hospital, or an installation I like very much on the right-hand side is the Church of the Rocks in Helsinki. Now, Kasambi is a system focused around lighting control. It supports occupancy sensors and other sensors. And one of the good things of this type of system is it provides an extension interface. So the aspect of extracting the data from the system has been addressed from the start of the design. So here's an example of how our partners, Holders Technology, have built a simple gateway to extract the occupancy and sensor data from the system. And this can then be used in a floor plan to track the utilization of the different offices and to schedule the cleaning. And of course, the underlying scheduling, the logic behind that can be very easily adjusted. So instead of saying, I do cleaning if an office space has been used for 8 hours, which was the standard case maybe before, now I have to say an office space needs to be cleaned whenever the space is vacated, no matter how long it has been in use. And the use of this type of technology makes adaptation to such an unexpected use case very quick and easy. Now let's give a second example of a more complex and more powerful system. So of course, this being a talk in LPS with Home and Bregenz, I was thinking of Zoomtobel Group, another partner with whom we work very closely. Zoomtobel has provided a system in digital services where they have a Bluetooth wireless mesh for key office use cases. So this is now something that starts to look a bit closer to what we are looking, because this has from the start been designed to track desk utilization, office space utilization, to track the ambient air quality, CO2, for instance, which suddenly became a very important use case. It allowed positioning and it provided people counting data. So as an example, here's an installation from Junto, one of the references that they did in the Nestle building in Vevey. So this installation integrates not only desk and space management, but also the sensing for air quality, CO2 and VOC, and additional sensor parameters. And this lighting management system, again, remember, very important, not only collects the data, but also provides them via both building automation system, a local API, and a cloud API. And based on such cloud API, you can then very simply put different functionalities, different dashboards on them. I'm fairly certain when they installed the CO2 sensor into the building, or when they installed the desk utilization sensors in the building, they had not the COVID pandemic in mind. But now, due to the architecture of the system, they can very easily reuse this data for unexpected use cases. So they can create interactive building plans, see where the navigations are, and execute contact tracing. Now, a final example is our partner Ingi. This is something that I've presented already at the LPS in 2019. At that time, Ingi had started a collaboration with the University Medical Center of Utrecht to address the operational challenges of running a hospital within the context of a smart lighting control system. The original problem that they wanted to solve at that time was that in a hospital, you are constantly looking for things. You're looking where your staff is, where the next nurse is. You're looking for machinery, for equipment. On all of this is usually there. You just don't know exactly where it is. So they did a lot of studies and found that between 15 to 20% of working time is spent on looking for things. And this led not only to operational inefficiencies, but is also led to additional capital investments, where the hospital would simply stock additional supplies to make sure they always had something at hand without extensive search. So this was the original use case they wanted to address. They wanted to understand how a lighting system can not only provide comfort, but also increase operational efficiency. So the way it's implemented is again an open network, in this case built around a wirepath mesh that allows integration of Bluetooth sensors, like for instance our multi-sensor, our switches, but again, very important, it's an open system, also third-party devices. So this is for instance asset tracking beacon that is attached to equipment in the hospital. There were small gateways that could be very flexibly set up to track assets at variable locations. And all of this data was then provided via Cloud API to dashboard. And with this, of course, you're in an ideal position to address a challenge like COVID. You have already your asset tracking system. And now if you're able to track the location of your personnel, which is something you can do in hospitals, but possibly not as easily in other workplaces, then it's very easy to include the COVID status as a parameter and extend your static use case that was previously important. Where is an asset? Where is a person? Where is stuff? To dynamic use cases. Who was in contact with a person? And this is allowed very easily to adapt the system towards the COVID use cases, where you can see what is the situation, what is the staff availability, what is the COVID exposure in this hospital. So these are three different use cases that show three different levels of integration, but all highlight the same tune. And this is really what we learned. COVID provided new challenges, but also new opportunities for smart building systems, especially those built around lighting. So of course, the challenge was we had an unexpected use case that provided very limited, practically no reaction time. But the upside, the opportunity is that the demand for IoT data solutions and the visibility of the importance of this type of solution has increased. The simple data that you get from your lighting system, such as occupancy monitoring data, became suddenly very valuable. And the focus on ease of installation, operation, and modification became very obvious to customers. So right now we have many projects where customers no longer ask, is this really a benefit? What do I need it for? What is my gain? But the discussion has shifted to how can we enable this to be sure we can address future use cases. So we see right now utilization monitoring, occupancy monitoring being a lot more asked. So these type of use cases can only be provided by data-driven systems. These systems need to be easy to adapt. The ability to adapt to new use cases has to be considered from the start. We at EnOcean work to provide sensor data for unknown and known use cases. We provide these sensor data from energy harvesting sensors that do not require maintenance, that are easy to set up because they are wireless. So please contact us if you're interested to make your systems ready for current and future challenges. Thank you very much for your attention.